Good morning, everyone. So today we are going to solve several examples of such cross sections to calculate the moment of inertia. Right. So here you can see the first of all we have one L-shaped cross section, and this L-shaped cross section is having the dimensions as mentioned here. This one is a 140 mm, the width is a 15 mm, and this one is a 100 mm, and this has a thickness of 20 mm. Right. So the job is to you have to calculate moment of inertia of this given cross section. So what is your first job? Alright, everyone, please listen me very carefully. Your first job is to align this cross section. Listen me very carefully. To align this as well as any cross section for which you have to calculate moment of inertia. Alright, so you have to align this cross section like which is having the left hand side coordinate on the y-axis. So you can say this is a y-axis, correct? And you can say this one is a bottom side coordinate which are exactly on the x-axis, correct? So you have to just touch this cross section on the x as well as y-axis in this side, alright, left hand side as the bottom side. And if it is fitted here, then this one is a proper alignment of this cross section, and it will be very helpful to calculate the moment of inertia very easily. Alright, so this is your first job, to align this element in the x and y axis. So here right now this one is your origin. Alright, origin means when this axis initiated on the positive side, or rather this vertical y axis. Okay, fine. So this one is the cross section, we align this section. Now our job first is to calculate the CG of this element. Alright, so how exactly we can find out the moment of inertia, as we already discussed about the introduction portion. Alright, so here we have to calculate the CG, we have to calculate the moment of inertia. So our example in this case, the external will ask you such like, please calculate moment of inertia of this section about its centroidal axis. So there are two centroidal axes. So first of all, we have to locate the centroid of this cross section. So you have to find out the CG of this cross section, and at the centroid, you have to mark the centroid and the axis passing through the centroid. You can say they are x-axis or y-y axis, alright. And about this, both the axes, you have to calculate moment of inertia. So first of all, our job is to locate this centroid, right? Then after we are going to calculate the moment of inertia of it. So that's why I insist you all, so please you have to prepare one table. Alright, so you can see this is the table, as all of you can see it very clearly. Okay, so this one is the table. First one is a section. Alright, so here is a section mentioned 1 and 2. So what is your job? Just look at here. This one is the cross section, so you have to convert the cross section into the two section, all right, in a basic known shape. So I am just cutting down this section from here. So this one is the above side one is a section 1, and the below side one is a rectangle, is a cross section 2. So I just here the imaginary sections, all right, I just put a marker line here. All right, you don't have to make a mark line, just I am here mark a line for the reference. Section 1 and section 2 both are the rectangle now, all right, both are the rectangle now. So your job is to calculate this moment of inertia of this section 1 and 2. So here is the coordinates x and y in mm, right, for section 1 and section 2. So you have to just draw this table first to calculate the moment of inertia of any section, but we are going to one by one, and after that you have to just prepare this table to calculate the moment of inertia. In the first, x and y. So what are the x and y? Let's discuss in this detail. So x and y, alright. So these are the rectangle, and you know this rectangle has a centroid at its center, and this rectangle, the one section 1, is another rectangle which has a centroid at here. Alright, so these are the centroid of this section 1 and section 2 as they are rectangle. Alright, so they are here. And if you are calculating the centroid of x, alright, so x means you can see I'm going to mark it here from this centroid. Alright, so origin to centroid. So this one is a x of section, this one is the x of section 2. Alright, so this distance is x of centroid 2, and the above side this one. Alright, but what is the y? So y is here, so you can see properly this one is origin to centroid offset. So this one is the y for section 2, centroid to the origin, the offset, right, the offset. So this one is a y. And what are the x and y for section 1? So for section 1 you can see this is centroid axis, this is origin, so this is x, this one is the x for the section 1. Alright, and what is the y of section 1? So you can mark it here from origin. Alright, so you can say this is a y for section 1. Alright, so what is the y? So you can say this is a total 100 and this is a centroid, so this distance, alright, for this distance only, this distance is 100 by 2, it's a 50, and you have to calculate from origin, so you have to add 15 more, so 50 plus 15, so it's a 65. So this y is equal to 65. Please, once again I am going to repeat it. From this CG to the section 1 has a boundary here, so this one is a half, so this one is 100 by 2, so it's a 50, and this y is from origin, from here. Alright, so this one is a 50, and additional this distance you have to add, which one is a 15 mm, so this y will become 50 plus 15, so it's a 65. Alright, and what is this y of this section 2? So this y is equal to, I can say this is a 15 by 2, so you can say it's a 7.5 mm. Right, is a 65 mm. What is the x value? So x value is a 20 by 2, as it's a rectangle, now it's as a half. Right, so x is equal to 10 mm. Right, and what is the x of section 2? So x of section 2, this is a total 140 and this will be the half, so x is equal to 70 mm. Alright, so we have all this value of x and y. So now we are going to calculate these values in this table format. So x for section 1, alright, x for section 1 is 10 mm. Here the unit is mentioned here. Y for section 1 is a 65 mm. Okay, x for section 2 is a 70 mm, and y for section 2 is a 7.5 mm, that we already calculated. Alright, now area, and both are rectangle, it is very easy to calculate an area of this, both the rectangle of section 1 as well as section 2. So section 1 has a dimension of 100 and this will thickness is 20 mm, so the area 100 into 20, it's a 2000. And for the section 2, the area will be 15 into 140. Alright, so you can say the 40 into 5 times is a 200, and the 100 1400. Right, so you can say it's a 500 and 200, so 700, and 1400 plus 700 is a 2100. All right, so 2100, it's a cross section area of section 2, as it's a rectangle b by d. All right, so you can place here the area of the first cross section, which one is nothing but a 2000 mm square, and for the section 2 the area is 2100 mm square. Now what you have to do, you have to calculate a into x. So here is a, here is the x, so whatever the values are here, you have to just multiply it, and just you have to put here the 20,000 first, then you have to multiply a into y. It's a 2 times 65, so 125, 130. All right, so 130, so it's a, you can say it's a 1,30,000. All right, so it's a 130. And ax and ay for section 2, so it's a 2000 and it's a 70. All right, so sorry, 2100 into 70, so you have to calculate it and you have to put a value you can have this calculation is a 2100 into 70, so you can say it's a ax is a 1,47,000 if you can multiply this both the figure a into x, alright, as it is mentioned here, a into y. So 2100 into 7.5. Okay, so it's you can say it's a 75 multiplied into 210. So if you multiply this 7.5 into 2100, then you can have this value 15,750. Alright, so this one is your answer. So it's a 15,750, and here is a ixx and iy. But before going to this calculation, our first job is to calculate the centroid of this overall L section, not section 1 and section 2, alright, which we are very familiar with about the centroid of the section 1 and section 2. But the centroid of the entire section, so that's why you have to calculate the equation, and you already did the center of gravity. X bar is equal to summation ax divided by summation a. So here we have ax, so we are going to take a summation of here of this entire row. So it's 20,000 plus 1,47,000, and you have to take the summation of this ay also, as it is y bar is equal to summation ay divided by summation a. So as per this formula to calculate this centroid of the given cross section, we are going to take the summation of a, summation ax, summation ay. Alright, so summation a first, it's nothing but a 4,100. Alright, you can say it's a sigma a. You can say sigma ax value, you can have this value 147,000, so you can say 1,67,000. It's a summation of this ax, and summation ay is a 1,30,000 plus 15,750. Alright, so you can say summation ay is nothing but equal to 1,45,750. Alright, so this one is the summation ay. So x bar and y bar which you want to calculate is nothing but, so summation to calculate the x bar, as it is a sigma ax divided by sigma a. Sigma ax we have this value, and sigma a is equal to 4,100. So we can calculate x bar is equal to 1,67,000 divided by 4,100. Right, and the answer we are going to be that, but y bar is equal to summation a divided by summation n. So 1,45,750 divided by summation a is 4,100. So if you calculate this x bar, then you can have this value is equal to 40.73 mm, and if you calculate this y bar, then you can have the value is equal to 35.55 mm. Alright, so you can say these are the coordinate of your centroid of the entire L section. So you have to mark this coordinate on this given figure. Alright, so let's mark these coordinates on this given cross section. Alright, so 40, the answer is 40.73 and 35.55. So from the origin, 40 mm, so you can say it's a 20 mm, so it's a 70 mm, so 40 mm is such around here. Alright, so I'm going to reference a small dash line, alright, which one is not a dark one, which one is a very light handed drawn this reference line. Alright, and you have to draw also uh, the y bar, which one is the 35 mm. So it's a 15 mm, and you have to go up 15 mm up to 20 mm. So it's a 35 and 35.55. So which may be around at here. Alright, not exactly, but you can say as a rough image, it would be here. So this one is the coordinate, alright, which is cross sectioning. As you can mark this dash line, and you can have this distance, alright, from here to here. It's a, you can say 35.55 mm, alright, and the distance from the coordinate to origin. So you can say the distance you can take from here to your coordinate x. This one is 40.73 mm. Right. Now you have to draw a dark line which one is passing through this coordinate, and you have to draw another dark line which one is horizontal passing through this coordinate. So the horizontal line is represented finally as an x, and the vertical line dash line which one is finally represented as a y. Right. So this one is the x-axis and this one is the y-axis, which one is passing through this centroid of this entire L section. Right. And here you have to solve the moment of inertia of this entire L section about its centroidal axis. So x-axis and y both are the this y as well as this x-axis both are the centroid axis which one is passing through the centroid of the entire section. So you have to calculate the moment of inertia of this entire section about this x-axis and y axis. Alright, so we are going to calculate the same. So here is your table, and in table this one is the ixx and iyy. And right now, as per the introduction portion, you are already aware about this. Both are the cross-section rectangle, and for the rectangle ixx and yyy, these both equations are known. It's a bd cube by 12, and iyy is nothing but a db cube by 12. Alright, so we are going to calculate the same for this given cross-section. Alright, so here is these ixx and iyy. So ixx, alright. So here is the rectangle. You can see the rectangle here, and we are going to calculate for the first one here, and the ixx of this rectangle. Alright. So here it is a calculating as a b, and here it is a d. Alright. So bd cube by 12. So b is a 20 mm and d is a 100 mm for section 1. So as per this equation, you can mention here it's a b is a 20 mm, d is a 100 mm cube divided by 12, and the answer will be your ixx of the section 1. And for the section 1 iyy, so in reverse order you can say d is equal to 100 mm, b is equal to 20 mm cube divided by 12. So you can have this iyy of this section 1. Similarly, you have to calculate ixx and iyy of section 2. So it is the section 1, so ixx1 and iy1, I am just give the name arbitration like here, right? And ixx2 and iyy2, right? Because there are total two sections. So ixx2 is nothing but a same equation, bd cube by 12, and here it is a db cube by 12. So for this section, you can say this one is your b, and this 15 mm is your d, right? So what is the b is a 140 mm, so it's a 140 into 15 cube divided by 12 is the ixx of section 2, and iyy of section 2 is just in the reverse order, 15 into 140 cube divided by 12, right? And the final answer will be your ixx and iyy. In the examination, you don't have to do this calculation, you don't have to show this calculation, you have to just directly put this value in the table format as you know the equation already, right? And already you have the b and d values over that equation. So here is just for the reference, here is just for the explanation of this calculation of ixx. So these are the moment of inertia of this section 1 and section 2 about an axis which one is passing through that centroid. So here the ixx is this moment of inertia is passing through this centroid, and here the ixx of section 1 is this axis, alright. So it is of this cross section, this axis, this cross section. So ixx1 is the moment of inertia of this section 1 about an axis passing through its centroid. Here is the ixx of this section 2, ixx is the moment of inertia of section 2 about an axis passing through its centroid, you can say. And iyy means the vertical axis here, and here it is the vertical axis which is passing through this centroid. So these are the moment of inertia of these different two sections about an axis passing through its centroid. But we have to calculate the moment of inertia of this entire section about an axis which one is passing through the centroid of this entire section. All right. So this one. So we have these values. So we know that we have moment of inertia, and this section is at the distance, at some distance, you can see at some distance from this axis, right? Even this section is at some distance from this axis, even this section is at some distance from this axis, even this section is at some distance from this axis. So you can say you have the moment of inertia of this section, and this section is away from such axis. So here you have to utilize the theorem of parallel axis, and theorem of parallel axis is clearly states that Ix is equal to, or in the previous case in the explanation it's IAB, but here it's axis, so I am going to mention is the Ix is equal to Ixx plus A S square. Alright, this is the equation, and as is the distance from this axis to the about an axis about which you have to calculate moment of inertia of the section. Alright, so A S square. So H you have, area you have already, Ixx that you already calculated. So here you require Ix. So let's just put this answer of this inertia of Ixx1, Iyy1, Ixx2, Iyy2. So here are the mentioned moment of inertia. Ixx1 is a 16.66 into 10 raised to 5, and all has the unit of mm raised to 4. Iyy1, as per this equation, it is calculated 66.66 into 10 raised to 3. It also has the unit mm cube. Ixx2, which one is basically 39.375 into 10 raised to 3, also has the unit mm raised to 4. Sorry, the previous unit is mm raised to 4, and Iyy2 is also 15 into 140 cube divided by 12 is 3.43 into 10 raised to 6 mm raised to 4. So right now you have all these values, so you have to just put these values in the table format here, right? So Ixx of section 1 and Iyy of section 1, which is already calculated. So let's see the value, and we can drop the same values in the table format. 16.63 into 10 raised to 5 and 66.66 into 10 raised to 3. So we can place this value 16.66 into 10 raised to 5, and unit is mm raised to 4, and Iyy is 16.66 into 10 raised to 3, right? So both has Ixx and Iyy of section 1. And similarly Ixx and Iyy, which are calculated as the previous case, 39.375 and here 3.43. Alright, so you can say here it is a 39.375 into 10 raised to 3, right? And the another moment of inertia, which is 3.43, right? So you can say 3.43